Okay, so 3.3, we're going to look at cumulative relative frequency distributions and kind of what happens with a histogram if you're not doing like a single data, unlike yesterday. So relative frequency histograms, a relative frequency histogram looks the same as a regular histogram, except that it'll have relative frequency, again the percentage, rather than frequency on the vertical axis. So relative frequency histograms are particularly useful when comparing distributions with, again, different sample sizes. So here's the stem and leaf plot for student weights, again separated by male and female. Since this data is continuous, there's no natural categories. In this case, we'll define our own categories. When you're defining your own categories, those are called classes. So there's no perfect way to create classes, but classes should always be the same length, never overlap, or leave any gaps. Again, ideally you should use between 4 to 10 classes. So what we're going to do, make a frequency distribution and relative frequency distribution for the data for combined male and female weights. So to save us some time, I already counted. Combined, there are 79 male and female weights. So what we're going to do, I think that's too bright, is we need to go from 100 to 230, 240. So I'm going to make my class interval 20 pounds. Because I think that'll give us 7 classes, which I think is a good amount. So when you do your class interval, you're basically going from 100 to less than 120. And then I'm going to go from 120 to less than 140. 140 to less than 160. 160 to less than 180. 180 to less than 200. 200 to less than 220. And 220 to less than 240. Okay, now we'll get rid of the less than sign. I'll talk about that in a second. So for the frequency, you just want to count total. So 100 to 120, that was easy. There's only 3 of them. 120 to 140 is a lot. But again, I'm not counting the 140s. I'm only counting to 139, technically. So that's 21. 140 to 160, 24. 160 to 180, 19. 180 to 200 is 5. 200 to 220 is 3. And 220 to 240 is 4. Okay, I counted these, so just trust me on the numbers. But if you want to go back and count, you can. Now I'm going to go through and do the relative frequency for each. So again, we're dividing by 79. So, I'll put that there. I don't think you can see it. I'm going to do 3 divided by 79. So I'm going to do 0.038. I like to round for relative frequency at least to 2 decimal places, if not 3. 21 divided by 79. 0.266. 24 divided by 79. 0.304. 19 divided by 79. 0.241. 5 divided by 79. 0.063. 0.038. And this one's 0.051. So there's our frequency, there's our relative frequency for the combined weights. So notice when we're doing our classes, it's kind of annoying to like write the less than 120, less than 140, less than 160. So in this class, it's kind of just assumed that it's less than. So what if an observation falls exactly on a boundary? As convention, we will put boundary values into upper classes. For example, suppose you decide on class lengths of 10 pounds, starting at 100, then the boundaries would be 100, 110, 120. but the classes would be from 100 to 110 would just be like 100 less than or equal to x less than 110. So if an observation is 110, it would fall in the 110 to 120 category. So you always go up. So you don't necessarily need to write the less than every time. So now we're going to do a frequency histogram for our table. So we're going to have frequency on the side, title, weights of male and female students. Okay, now the highest one is 24. If you go up by 2, you get to 22. We're going to go off for 24, but that's okay. Okay, so our x-axis is the weights. So again, I'm going to start at 100. And every other one, I'm going to, so each one's 10 pounds. Okay, so for 100 to 120, we had a frequency of 3. And again, I'm going to show you just so you guys can see it better. 120 to 140 was 21. I'm going to go all the way up and over and down. 140 to 160 is where we had 24, so I'm going to go off. $160 to 180 was 19. $180 to 200 was 5. 200 to 220 was 3. And then 220 to 240 was 4. Okay, so that's what our histogram looks like. If we wanted to go through and sort of do socks, just so you guys can see kind of a review of yesterday, I would say this is skewed right, because the tail will be there. The only thing with a histogram, there's no way to tell. There's no outliers, gaps, because unless there is a gap, that would be the only way to tell if there was an outlier. So you kind of lose that in a histogram, unlike a stem and leaf plot. And also the median cannot be as accurate because you don't have the numbers. So here I'm just going to say the median is between 140 and 160 pounds. The actual, I went through and put all the 79 numbers in my calculator, is 150. But it's kind of like the middle point. So again, you're trying to see, okay, so it's like somewhere in here, but you don't know exactly. So you sort of lose that kind of stuff. And then the range, again, all we know about the range is that it's 240 minus 100. So it's 140 pounds. Even though the actual range is 136. So the biggest thing that histograms tell you is the shape. Everything else, because you lose the actual data, you're just more estimating. There are methods for creating histograms with unequal classes, but we skip them. If a frequency distribution has a non-bounded class, such as 250 or more, we don't make one. So we kind of skip that. That's different stats class. So that kind of tells you about histograms in terms of with classes. Now on the next page, we're going to look at a new type of distribution, and one we don't see too often, but every once in a while it gets up there. Instead of wanting to know what percent of data falls in a particular class, we often want to know what percent falls below a certain value. So to make this possible, we compute, it's a kind of a long word, so I'm going to start it up here. Cumulative relative frequency. So cumulative relative frequency for each class, which is the sum of the relative frequencies of that class and all the classes below it. So here we have a cumulative relative frequency. Here we have the score on a test, the frequency, the relative frequency. We're going to do the cumulative relative frequency. So all we're doing is adding. So I'm going to zoom in so you can kind of see what I'm going to do. So the cumulative relative frequency for the first class is just 0.01. Now to get the cumulative relative frequency of the next class, I'm going to add these two together. So I'm going to take 0.01 and add 0.035. So I get 0.045. Then I'm going to add the next one. So plus 0.045. 0.09. So I'm going to keep adding. So plus 0.06. So 15. Plus 0.115. 0.265. Plus 0.17. 0.435. Plus 0.24. Oops. Well, I'll just go off my key. 0.675. 0.87. 0.965, and then the last one should be 1, and then you have 1 for the total. So you just keep adding. So let's answer some questions. Let's pretend we just know the cumulative relative frequency. So what proportion scored less than a 30? So less than a 30 would be 0.09. 30 or less. So if we just knew this one. Less than 90, we just go to the 90 part, 0.965. So 96% of my kids scored less than a 90. What proportion scored between, or at least a 40? So at least a 40 members, 40 or more. So if I just knew this column, what I would do, I would take what we call the complement. I would do 1 minus the people who scored less than 40. Well, less than 40 was 15%. So 0.85. So if you have a greater than, you can just subtract the less than. At least 70, I'm going to do the same thing. At least 70 would be 70 or more. So I'm going to do 1 minus that they got up to a 70. So 0.675. 0.325. What about just a 45? The percent that's going to 45. We don't know that. So that's again the one drawback. You don't know a specific value, only less than or greater than. What about between a 50 and a 70? Again, if I just knew that last column, what I would do is I would take the 70, 0.675, and I'd subtract, that got up to a 50. So 0.265. So 0.41. Okay, obviously if you had the other ones you could add, but we're pretending we just know this one. So the graph of a cumulative relative frequency distribution is called OGIVE. This is pronounced ogive. The name's not in the book because our book is old, but it's called an ogive graph. Sometimes they'll just say a cumulative relative frequency graph. It's just kind of long to say. So let's try and graph one. You'll end up seeing it ends up sort of being like a curve. So test scores. So on the bottom I'm going to have test score. So 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And then on the side we have cumulative relative frequency. So again, go all the way up to 1. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. So what you're going to do, you're not going to create, it's kind of weird. You're not doing a histogram. We're going to put dots where the cumulative relative frequency is, and then we're going to kind of connect them. Okay, so it's going to end up being like a curve, but we have individual segments. So if you want to watch it and then go back and do it, you can do that. So 0 was 0.01, 0.045, 0.09. I like to go and do all the dots, then connect them. 0.15, 0.265, 0.435, 675, 87, 965. Uh-oh. I feel like I messed up. I did. I missed one. 0.01, 0.045, 0.09. Oh, there's no 0. That's why. Okay. Sorry. So this one should be down here. Well, ignore the top ones. I wish I had white out, but I don't. And I'm lost. There we go. 0.15. 0.265. It's like, wait, I'm off. There we go. Because the 1 should be at 100. So look at my lower dots. So for 0, you should start at 0. Oh, and I told you I'd connect these individually, but that's okay. So as you can see, it's sort of a curve. Okay, again, ignore the top ones. Like I said, we don't do a ton of these, and if I'm going to give these to you on a test, I'm probably going to give you the graph, and then you have to talk about it. So let's use this graph, again, pretending my other dots are not there. What we'll see a lot with these graphs is a percentile. So the percentile of a distribution is the value in that distribution such that P, the percent of the observations, lie at that level or below. So you guys probably get percentiles like when you get your SAT score, like when you were kids, your parents would take you to the doctor and they'd be like, okay, they're in the 80th percentile for height, the 10th percentile for height, something like that. So it's just where you're at, everybody that's beneath you. So the 20th percentile, I'm going to look at my answer key for the graph since my graph kind of got screwed up. So here's my answer key for the graph. So if I'm looking at the 20th percentile, I'm going to look where 0.2 is. So I'm going to look here and it's between 40 and 50. I'm going to say about 41%. So again, we'll say about 41%. Now again, if we look at the, yeah, that's fine. Where's the 70th percentile? So the 70th percentile would be 0.7. So I would say about a 71%. The median, now the median you need to think that's the 50th percentile. So, because that's the middle. So if I look here, 50.6, about 61%. Again, these are all approximations, so we'll put little squigglies. So it doesn't tell you like exact, but it tells you about. Another thing we can do with cumulative relative frequency is I'm going to give the following ogive, construct the corresponding relative frequency. So I'm going to go through and take this and do each individual relative frequency. So again, you can see how it's like a curve all the way up to 100, but like it's not like one continuous curve. It increases and decreases separately. So all we're going to do is do the opposite. So I'm going to have relative frequency on the left-hand side. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.9, 1.0. And I'm going to have amount spent. I'm not going to rewrite the title. So from 0 to 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So all we're looking for is the gap. How much? So here it went from 0 to about 5%. So I'm going to draw a little mini 5% on my histogram. From 10 to 20, it looks like it went up 10, 20%. Okay, from 20 to 30, it looks like it jumped another 20%. From 30 to 40, it jumped 10% because it went, or 15% because it went from 45 all the way up to 60. So 15%. From 40 to 50, it went up 10, just went from 60 to 70. From 50 to 60, it went up 5. 60 to 70 was 5. 70 to 80 was 5. 80 to 90 is 10. And 90 to 100 was 5. So I guess I could have made this not all the way up that high, but it's fine. So that sort of gives you that. We don't do that very often. Again, the biggest thing you're going to see like on a quiz or a test is probably like, here's the graph. Can you answer these kinds of questions? So it was a lot today, but again, we have some time before our Chapter 3 quiz and our test.